देखियो त देखियो you can see my screen.
Yes, yes, sir, yes.
Okay.
Hi, sir,
So
hi.
today is S8. यसोले के भन्नुपर्छ छैन because now we are used to
Yes, sir,
my
yes.
presentation. So though it's a ninth one, but the seminar itself on mathematics through the ages is the eighth one. First one was the motivation type of my mathematics, my life talk. So today's theme of today's seminar is Leonhard Paul Euler and Israel Mercedes Gelfan. Okay. We'll be talking about these two extraordinary mathematicians. One from the 18th century, Euler is from the 18th century, and Gelfan is from the 20th century. Then you can see the difference in the development of mathematics within these 2 centuries. So that is my aim for today. And also, I have some connection with these two mathematicians because they are Russians. Though Euler is not a total Russian, but he spent most of his created of his life in Russia, and Gelfan is a total Russian, but the last part of his life he spent in US, of which we'll be talking today. So these are two very extraordinary mathematicians. So first of all, let me show one slide here, but we'll first of all talk about Leonhard Paul Euler. The importance of this you can see is from the 18th century, and some time back, I got this 17 equations that changed the world by Ian Stewart, a prominent mathematician of the 20th century. So he said that these are the 17 equations that changed the world. Of these 17, two of them are of our interest today. So this one is from Euler, 1750. So in 1750, Euler gave the square root of -1, which is symbolized as I. Root of minus I. 1 is I, the symbol he gave there. That is the symbol he has given. And there's a very interesting formula called Euler's formula for polyhedra. E minus E plus F is equal to 2. E is the vertices, E is the edges of this polyhedra, F is the face of the polyhedra. The relation between this vertex, edge, and face in the polyhedra is E minus E plus F is equal to 2. These two you can see from the of the 17, only person Euler has 2 times mentioned here, others has 1 time. And up to 18 or 19, 11, up to 11, or even up to 12, which is 18th century, then comes the 20th century, 19th century, 20th century. So it starts from 300 BC, the Pythagorean theorem. Anyway, so Euler is just such an important because in this 17 equations that change the world, Euler's name has been mentioned twice. But that's why I thought that these are very extraordinary mathematicians about which we will be talking today, because we have to learn about such a extraordinary mathematician. So before going further to their life history, let's look at this relation V plus E. F is equal to E plus E. He has written in the other way that E plus F minus E equal to 2. So this is called Euler's formula for polyhedra. So if you have polyhedra, and then for a 3 pyramid, pyramid we see in what we see in 11 countries is not, Egypt is not 3 pyramid. The 3 pyramid is the prism we see in our physics practical. So it has 4 vertices, 3 edges, 6 edges, and face 4. And 4 pyramid which we see in Egypt, 5, 5, 5, 8, and 5, and cube, which we know very much, 8, 12, and 6. And looking at this relation, they derived a relation that E plus F is equal to E plus 2. But the greatness of this mathematician Euler is that the same looking pattern, E plus F is equal to E plus 2, he then continued to use the same relation as a Euler formula in this case. A connected panel graph with n vertices and e edges has the regions r equal to e minus n plus 2. So Euler's formula is generally regarded as this one. So v plus e plus e. They look very similar. You can see these two quantities equations are very similar. Right? Very similar. Here what happens is uh, R becomes the phase, and so it becomes very similar. Let me illustrate this formula here. So if you have a plane representation of a graph, it divides the plane into regions. For example, I have taken this graph over here. You can see there are closed regions here, R1, R2, R3, R4, and I5. This group as finite regions. The R6 is the remaining plane. And here you can see there are 10 edges. You can count it, there are 10 edges, and there are 6 vertices. So then the region here, connected panel graph with n vertices and e edges will have R is equal to region e minus n plus 2. So e is equal to 10 minus 6 plus 2 will give us again 6 region. Okay, so you see, so when you have such extraordinary mathematics, they can use the same formula in different parts or different sectors or different chapters or different parts of the mathematics. So that is the genius, we call it genius mathematics for that reason. Now let's go to the life of Euler. Leonhard Paul Euler, 1707-1783. This is photo taken very close to his time, starting with his childhood. So, Euler was born in Basel, a city in Switzerland, on April 15, 1787. His father is Paul Euler, similar. Mother is Margaret Rucker. He has two younger sisters, Anna Maria and Maria Magdalena. I have been to Basel some time back, only 2 years back to that place. For his father, Paul Euler was a friend of Bernoulli. We have already talked about the Bernoulli family, very prominent mathematics family. So there are two brothers. Bernoulli, Jonas Bernoulli was one of the prominent mathematicians. So Paul was very connected with Johann Bernoulli. So we have seen that Bernoulli are the foremost mathematician family in Europe at that time, in the 17th, 18th century. So this is, you can see, very nice city. That is a nice city. We are in Basel on 7th July 2019 on the way to Geneva. We made a stop there because it was the birthplace of Euler. Then we decided to make a forceful stoppage and have a photo. So I didn't have time to look at the city because I have some appointment at Geneva. His life related with his education. He entered the University of Basel in 1720 at the age of 13. You can see that this is why I call it extraordinary mathematician. He entered the University of Basel at the age of 13. Okay, so he entered the University of Basel in 1720 at the age of 13. You can see how fast he goes on his education system. He was studying theology, but he was not going to mathematics. He was studying theology, Greek and Hebrew in order to become a pastor. He wanted to be a pastor. He wanted to serve in a church. In 1723, at the age of 16, Euler completed his master's degree. So he only had 3 years university to complete the master's degree. But his master's degree was again not in mathematics, it was in philosophy. And his work was, he compared and constructed the compare and contrast the philosophical ideas of Descartes and Newton. So when he was working on his thesis, master's thesis, so he worked on Descartes and Newton, where his interest in mathematics grew. And completed PhD at the same university in 1726 at the age of 19. You can see he entered university at the age of 13, and within 6 years, within 3 years, he completed master's. Of course, within 3 years, he completed his PhD. So you get, that's why I call him an extraordinary mathematician. But many mathematical works during his time in Basel. By 1726, at the age of 19, has already paper in print, a short article on isochronos in mainstream media, more related with physics. In 1727, after 1 year, was another article on reciprocal trajectory, more on mathematics, chemical mathematics. We did an entry for a 1727 Grand Prix of the Paris Academy on the best arrangement of mast of the ship. I have already talked about this academic prize of Paris Academy when I was talking about Sofia Kovalevskaya. But in 1727, he entered for the prize, but he won only second place. The first place that year was won by Perry Boger, the mathematician, 1698, 1758. But subsequently, in subsequent years, not consecutive, in subsequent years, he won this annual prize 12 times, not only once. So he could get Grand Prix of Paris Academy, he got 12 times. Now, from Berlin, he moved to St. Petersburg, Russia, arrived in St. Petersburg, Russia on May 17, 1727. He mastered Russian and settled into life into St. Petersburg. So, from 1727, he started working his life and spending his life in St. Petersburg, Russia. And just for the mathematician, let me remind two things related to St. Petersburg. One is last year, and last year also International Olympiad was to be held in St. Petersburg, Russia, but due to COVID, they couldn't have it physically. They have to do it virtually. So for Nepal, I am the country representative, so I have to organize International Olympiad for St. Petersburg in Kathmandu this year and previous years also I have conducted IMO for St. Petersburg 2 times. And next year in 2022, International Union will organize ICM 2022 in St. Petersburg. So those who are interested to participate in ICM, International Congress of Mathematicians, on the International Union IMU, they can now, that registration is open, so you can go to the web page and then ICM 2020 web page, and then you can register for participation in the ICM 2022 in St. Petersburg, which will be in July, August next year. So when Eulers settled in St. Petersburg, he rose quickly through the rank in the academy and was made professor of physics in 1730. You can see he was a versatile type of person. He started with theology, I will say, and then he became a professor of physics in 1731. And another Bernoulli family, Daniel Bernoulli, about which we have talked some time back, left St. Petersburg to return to Brazil in 1733. Euler was appointed to be the senior chair of mathematics. So the position held by Daniel Bernoulli in St. Petersburg was taken by Euler in 1733. On January 7, 1735, after 1 year, he married Catherine, daughter of a painter, Russian painter. They had 13 children, you can see. And on those days, they have so many children, but unfortunately, only 5 survived their infancy. All the 5 children passed away at the age of infancy. Made some of his greatest mathematical discoveries while holding a baby. So there were 13 children. So only 5 survived, but there were children all around. Made some of his greatest mathematical discoveries while holding a baby in his arms with other children playing around his feet. So these children didn't stop in his creation of mathematical theorems or creations. Let's now look at his work, start of his work. So in St. Petersburg, he started publishing of many articles. He wrote a book called Mechanica, more related with physics, but more with mathematical formulae in 2 years' time, 1736-37, where he presented Newton dynamics in the form of mathematical analysis for the first time. And won the Grand Prix, as I mentioned earlier, of the Paris Academy in 1738 and 1740 and many others, 10 more times. Start was from 1738, 1740 and it continued 10 more. He came back to Berlin, arrived in Berlin on July 25, 1741. After working vigorously in St. Petersburg, he came back to, not Berlin, but he came to Berlin on July 25, 1741. And in Berlin, he was, in 1741, when he came back, he was appointed to the Academy of Sciences in Berlin. In 1742, he became the honorary foreign member of the St. Petersburg Academy of Sciences because he was a Swedish citizen. So he became a honorary foreign member of the St. Petersburg Academy of Sciences, which was a very strong academy at the time, more stable than the Academy of Sciences in Berlin. Academy of Sciences in Berlin was very huge, but St. Petersburg Academy was very deep type of science academy. In 1744 to 1766, you can say 23 years, he became the director of a national class of Academy of Berlin. Now, this Academy of Berlin is very prominent and very interesting. We'll talk about this Academy of Berlin many times today and sometime later also. So he spent 25 years in Berlin. So his 25 years in Berlin were very busy and productive. So Euler lived and worked on in this building. Plaque is there. This is the photo I have taken in August 1, 2019. So Euler lived and worked in this building. Of course, this building has been restored, not the original one where he lived from 1743 to 1760. All Euler has spent here. This plaque. So one of the book which he has written in 1736. It is a very rare book and foreign interest. Cost of this book at present is somewhere between $6,000 to $9,000. So it's such a rare book. So only who are very curious and are really can buy this book. Now, Academy of Sciences, where Euler worked, is known as Berlin Academy of Sciences or simply as Berlin Academy of Sciences. It was founded in 1700 by Gottfried Wilhelm Leibniz, which is another very prominent mathematician. So he founded this academy in 1700, 321 years back. And this Academy of Sciences was created before a university was founded in Berlin. University of Berlin was founded in 1708. Its members included Jacob, Wilhelm, opposite Wilhelm is there, Grimm, there are several Wilhelms. Wilhelm Grimm is there, Wilhelm and Alexander von Humboldt, so there is a university, Humboldt University after him. Yes, Metier, Theo Movement States, Albert Einstein also worked there, Planck also worked in this academy. So this academy has produced 18 Nobel Prize winners, shaped this history of this Academy of Sciences. You can see how strong is this academy. This is two minutes from the Academy of Berlin, which I have scanned over here from their webpage. The one was from 2 to 1746, and another is from January 1770. I have put this over here so that I can somewhere here you will find the name of Euler also here. Euler is here. You can see Euler is the number here, and member Euler was the member here, right here. And so this over here. Anyway, so Euler was working with it. This academy in 1746, 1761, he was working here. One is from 1746, one is from 1761. So we means my wife. So we visited this academy on August 1, 2019. We were in Berlin on that day. We were invited by the president of this Academy of Sciences in Berlin, and the person who invited me, he was the General Secretary of International Mathematical Union for 2 consecutive years when I was president of the Nepal Mathematical Society. So we met him several times, and when I told that I'm visiting uh, Berlin on way to US, he invited us for a lunch and visit the academy, historical academy. So on the wall, all the presidents' photos were here, starting from Lebanese, all the photos were. So this is the last president here, 33rd president here. So, we visited uh, the academy of the country at the invitation of this president, Professor Martin Grochel. Martin Grochel is a very nice person. He didn't go for the president of IMU, International Mathematical Union. So he was invited to become the president of Academy of Sciences. So he chose this job rather than go as the president of International Mathematical Union. So photo in his room and on the door leading to the secretary. So you can see from this balcony we are looking at various sites of Berlin, and we had a lunch just outside his academy, outside his academy. In Berlin, wrote nearly 380 articles during his Berlin period. Besides the great mathematical success, he also served on the Library and Scientific Publication Committee of the Berlin Academy, was a government advisor on state lotteries. The lottery is also in many ways connected with mathematics. Insurance also is connected with mathematics. Annuities, pensions, and artillery. So all these are some way connected with mathematics. So he was a government advisor on these matters. Wrote many scientific and popular science books. His most famous popular science book, not on mathematics, popular science book is known as Letters to a Princess of Germany. The princess to whom Euler wrote his famous letter was not a real princess, was Charlotte Ludovica Lucia. It was a daughter of a friend of Euler, with whom he would play music in the evening. This book was translated in many languages and published more than 40 times. So how popular, famous is this book, Letters to a Princess of Germany. So this is the cover page of the letter, that book. So this is Princess Charlotte Lucia. She is not a real princess, she is the daughter of his friend. So it is written as in this format, the first letter, and so on and so on. And the first English translation was done by Reverend Dr. Henry Hunter in 1902 in 2 volumes. In 1833, there was another edition by Davis Brewster with additional notes, and there in this new volume, in a new edition, here, this David Brewster also has included biography of Euler, and John Grimson, or person, has included the glossary over here. So this is book. In Berlin, his eyesight problem began in 1738 with strain due to his cartographic work, and that by 1740 he had lost one eye. So by 1740 he has lost one eye. But he didn't stop working. Made important discoveries in the calculus of variation, established identity for complex numbers, produced 2 treatises in analysis, introduction to analysis of the infinite in 1748, foundation of differential calculus with application to finite analysis and series in 1755. With only one eye has gone, so he had only eye working, and he still worked very intensively, as you can see here. St. Petersburg, he came back to St. Petersburg after his one eye was gone. In 1766, Euler returned to St. Petersburg. In 1771, Euler's home was destroyed by fire, his home in St. Petersburg. In September 1771, in the later part of 1771, Euler has surgery to remove his cataract. Nowadays, it's a very simple operation. In those days, may be a very not easy operation. Euler did not take care of his eye. He continued to work and after a few days lost his vision again. So after coming back to St. Petersburg, after a few years, he lost both his eyes and so he lost his vision. After his return to St. Petersburg, it was almost half his total work despite total blindness. So he was blind and he was dictating his scientific work, mathematical scientific work. So both of his eyes were gone. Because of the remarkable memory, he was able to continue with his work on optics, not only in mathematics, he worked on optics, algebra, and lunar motion. In 1770, he lost his wife, Catherine. They have lived for 40 years. So I have again put this photo so that then you can see this photo. You can see both of his eye has gone. First of all, this eye was born, and so this eye was. So he was totally blind. That's why if you carefully look at his portrait photo, then you see his eyes are damaged over there. Once the first wife was gone, he married the second one. The second marriage took place on August 8, 1770, with half sister of his first wife, okay, Salome Abigail this year. Two sons were born from the second marriage. There were 5 remaining children, and so 2 were there, 17 now. The 7. Euler died of a stroke on September 18, 1793. So Salome Abigail, the second wife, died on December 25, 1794. Lived for more than about 10 more years. Euler was cremated at Alexandria Nevsky Monastery, very famous monastery in St. Petersburg, along with the tomb of 2 famous writers, Tchaikovsky, more related with music, and Dostoevsky, very popular writer. Now let us look at the volume of work done by Euler during his stay in St. Petersburg and more in Berlin. Most of the work were done in Berlin, and then the remaining big volume were done in St. Petersburg, Russia. During his second stay in St. Petersburg, produced influential work in integral calculus, algebra, graphics, this is more related with light, study of observational light, navigation, and the theory of lunar motion. During his lifetime, he had more than 886 papers and books. Just imagine the huge volume of work he has done during his lifetime. So he has already said that when he came back to St. Petersburg again, one of his eyes has already gone. An additional 400 of his manuscripts were published after his death, nearly 50 years. So during 50 years after his death, more than 400 more additional works were produced, besides the 886 that were. So that means more than 1,200 works has been done by Euler. So volume. It says that if you want to read all his works, it will take year 2 life, not 1 life is enough to read all his articles. Of course, you can read, but you may not understand everything. His collected works entitled Eulerii Opera Omnia is contained in 80 volumes, many of which exceed 500 pages. You can now see the work, 80 volumes, where each volume contains more than 500 pages. The work in this collection are distributed as not only mathematics. 40% are on algebra, number theory, and math analysis. 28% are mechanics and physics. 13% is in geometry. 11% is astronomy, and remaining 3% are remaining here and here. Just like the princess over there. So this is the past work done by Euler. So no mathematician can surpass the works done by Euler. That's why I call it extraordinary mathematician. And during his work, he has introduced many mathematical symbols which we very easily and just take it as granted. Introduced and popularized several notational conventions. E for the base of natural numbers, E and pi for the ratio of circumference to diameter of circle, Fx, the functional value we write very easily, basically Fs, the modern notation for geometric functions just like log, sine, cos, I for imaginary unit, which we have mentioned, and this summation symbol, and delta for finite difference. So he has introduced many mathematical symbols. Now, at the end of his life, we will look at the Basel program. So Basel is his workplace. So there is a program called Basel program on series. Basel problem. The Basel problem is a famous problem in mathematical analysis, with relevance to number theory, was posed by Italian mathematician Pietro Mengolo in 1644. This is a photo of Pietro Mengolo, the 1626. He was born in Bologna, Italy, died in the same city, 1876. Problem was, Basel problem is determine the exact value of the infinite series 1 upon 1 by 4, 1 by 9. Actually, that is 2 square, 3 square, 4 square, up to k square. You can make an approximation. Numerical approximation has revealed that a series sums to a number somewhere in the vicinity of 5 by 5. Jacob Bernoulli, what we have talked about, 1654-1705, law of infinite series. Euler attended Jacob Bernoulli lecture in the University of Berlin. Some of his series Jacob Bernoulli studied. They have said that Jacob Bernoulli was very interested in such series. So Jacob Bernoulli studied and found that 1 plus 1 by 2 plus 1 by 6 plus 1 by 10 plus 1 by 15, which is 1 upon k into k plus 1 by 2, leads to 2 factorial. That is 2. And so this is some other celebrated closed form solution as the alternative harmonic series. This alternate harmonic series symbols are minus plus minus plus minus 1. It will give the sum as log 2. This is log 2. If you take the odd only, alternate odd series, 1 minus 1 plus 5, 1, value of pi by 4 is a good formula to find the approximate value of pi using this in this series. Jacob also found that in different series, k squared by 2 to the power will give us 6 factorial, k3, k cubed plus 2 to the power k will give us 10 6. So they are very interestingly really finding the sum of such infinite series. Eventually, he turned his attention to the series of this type, 1 by k pi, very popular important series, 1 plus 2 upon p, 1 plus 2 upon p, and so on. 1 by kp series of sum of 1 by k to the power p. Euler in 1730 introduced the zeta function. Now this is a very important function for mathematicians. Zeta function is similar to what it has been similar to this one. So the symbol is zeta, then when you call zeta, 1 from 1 up to power zeta series, and so on. Which is harmonic for s is equal to 1. If you put s is equal to 1, 1 plus 1 by 2, 1 by 3, series sum will be 1. And for s is equal to 2, it will be 2 square, 3 square, 4 square, it will turn into Basel program. The Riemann hypothesis, which is a very important, very interesting hypothesis, asserts that all the interesting solutions of this zeta function lies on a certain vertical straight line. This another Riemann hypothesis is a very huge, interesting mathematics. So if s equal to 1, we get harmonic series, which is divergent, but this divergent series also has a sum, because sometime back in School of Education, I have made a lecture on summation of divergent series. If you wish, I can repeat that sometime later. However, Euler calculate the difference. So it was a divergent formula. Euler calculate the difference 1 by n minus log n is equal to gamma. This is called, this number gamma is called the Euler constant. For physical T, we get the Basel series, as we said. Jacob failed to find the exact sum and pleaded for here. So Jacob tried Jacob tried many times, in many ways, he couldn't find a song, so he created over here. If anyone finds and communicate to us that which thus has eluded our efforts, greater will be our gratitude. So he gave some type of challenge. Euler introduced an infinite polynomial. So without directly finding the solution, what Euler did was, so he introduced an infinite polynomial, px is equal to 1 minus x squared by 3 factorial, x4 by 5 factorial. So you see, you should have 2, here you have 3 factorial, you have 4, the 4 plus 1 factorial, 6 plus 1 factorial. Anyway, this is like this one, where when x is equal to 0, when x is equal to 0, so this all term will be 0 and will have 1. So to find the roots of px is equal to 0, where x is equal to not 0, if x is equal to 0, we have a trivial solution 1. To find this root where x is not 0, Euler rearrange the series as follows. So he rearranged the series in this way. So he rearranged the series x by x, by x, and so that then we have this series. Now this upper series is nothing but it will be an expansion of sin x and sin x by x. So then we can find the roots of this px, that is px will be 0, if sin x will be 0, if this is 0, this will be 0. Not x is 0, if x is 0, it will be infinite. So it will be 0 if this is 0, which means that it can be 0 when x is equal to plus minus k pi. Sin x will be 0 when x is equal to plus minus k pi. So in this way, he found the roots of this polynomial. And he again factorized it with this px in this interesting way. In this interesting way, x 1 by x minus this, and so on, so on, so on. And he regrouped it in this way, 1 minus x squared. This 2 you can multiply, and in this way he gets this summation, right? And he compared the two forms, previous one, which we have put inside the bracket, and this one, and where the quotient of x4 and greater are not considered. So we take the first 4 terms only, and he then equated the quotient of x squared and found like this one. And finally, Euler arrives at the geometric solution that 1 plus 1 by 4 plus 1 by 1 by 8, that is 1 pi square. It will be value is pi square by 6. So Euler solved the Basel problem in 1735, which was post 91 order by Pietro Mengaro in 1644. So you can see how Euler worked, his style of working. So he introduced a new polynomial to get the value of this infinite series. And infinite series has a finite value of pi square by 6. Also, that is extraordinary way of doing mathematics. Now, some quotes about Euler. Read Euler is the master of us all, said Pierre Simon Laplace, other big mathematician, 1749. All his life, he seems to have carried his head the whole of mathematics of his day, both pure and applied, and we will prove this Feynman's last chapter. Euler calculated without apparent effort as main breadth as eagles sustain themselves in the wind, said Francis Harris, 1796. The study of Eulers' work remains the best instruction in the various areas of mathematics and can be replaced by no other, told by Carl Friedrich Gauss. Gauss is another extraordinary mathematician, 1717 or 1855. So since he's a legendary person, so there are stamps from different countries, yes, and Germany and UK. Now, that is enough for Euler extraordinary mathematician. Now we move to the another extraordinary mathematician. About Euler, you know, I think most of you know very much. But now this another type of extraordinary mathematician, general mathematics is Gelfan. I think that some of you may have already, they are Gelfan's theorem also, but most of you may not have heard about the life and work of Gelfan. So I think it may be very interesting for you. So he was born in 1913, and so in 2013, his centenary was observed throughout the world, and this was one of the postcards posted in the different web pages during his centenary, Gelfan centenary. The photos, different photos, testing for it, and a postcard over here. A short biography. It's very, his biography is also extraordinary and very interesting. He was born in 1913, born on September 2, 1913, in a small town, Krasny Okno, in Ukraine. Ukraine is on the north of Russia, on the south of Russia. In fact, my son studied his engineering courses in Ukraine. This Krasny Okno, if you translate it into Russian, it will be a red window. Krasny Okno in English, if you translate it from Russian, it will be red window. So this very small town, the south of Ukraine. So at the age of 15, so he tried to go to school. At the age of 15, he was expelled from the trade school. He didn't have interest in learning. He was most mischievous boy, and so he entered a trade school at a time. It was trade school were very popular on those days, and so he was expelled from school. And somehow he went to Moscow and lived with relatives. About his parents, we don't know the name of his father, but it is said that his father owned a mill, was considered to be a capitalist. Means his father was quite rich, and his mother's name also is not known so far. So we have they have been able to find a photo of Gelfan's parents. Very less is known about his childhood. He attended the only school in town where he was born, a small town, and his mathematics teacher could offer him nothing except encouragement. So this is the photo of Gelfan at the age of 3 in 1916. He was autodidact. He studied on his own. 1931, attended evening lectures at Moscow State University and other colleges. Though I have not mentioned over here. So when he wanted to, he was a dictator. So he wanted to study something. He wanted to learn a bit of mathematics. He was sent to his maternity uncle, who was living in a bigger city, and he would live over there and attended the school. But he was not satisfied with the teaching of mathematics in that school also. So he actually ran away to Moscow and lived in one of his relatives. And what he did is to learn more mathematics, he went to work at Lenin Library, biggest library in Moscow. So he became a book checker in the Lenin Library. So when he was working in the Lenin Library, Lenin was one of the biggest resource for other mathematicians also. And one of the professors from this Moscow State University visited, used to visit this Lenin Library very frequently. And one day he saw this boy, the book checker, doing some mathematics. And he was doing a bit advanced mathematics. He then asked him, how did you learn this? He said, I learned on my own. And so this professor then thought that this must be a very genius type of boy. So he took him to the Moscow State University where he was a professor. The professor I am talking is Professor Kolmogorov, which is a very big academician, mathematician, and also started a math school in Russia. So this is another big story maybe. Anyway, he took him to Moscow State University and admitted at evening classes which are being held in Moscow State University. In 1932, became a graduate student of Andrei Kolmogorov, so a mathematician, also started teaching at Moscow State University as an assistant professor at the mathematics department. So you can see he didn't have a formal schooling, but he was taking classes in the evening classes at Moscow State University, and Andrei Kolmogorov, the head of department, was senior most professor, gave him the task of teaching at the mathematics department in the same university. This is Moscow University, very prominent building, very built in the Stalin time. So this is myself in the winter in front of this Moscow State University, and my wife is there also. So 2009. You know, we just saw right. In 1935, at the age of 22, defended PhD thesis at Moscow State University without a college education and without completing high school. Now, this is why I call him an extraordinary mathematician. So he didn't complete any high school, he didn't attend any college education, but he defended his PhD thesis at Moscow State University, the topmost university of Russia, at the age of 22. In 1935, after 4 years, also started working at the Mathematical Institute of Academy of Sciences. This is a very highly research-oriented institute created by the Academy of Sciences. It's called Mathematical Institute of Academy of Sciences. So, fortunately, at 1940, became a Doctor of Science. In Russia, it is not enough to become a PhD. If you want to be a professor, you have to become a Doctor of Science, DSc. So, in 5 years' time, after 1935 to 1940, he became Doctor of Science at Moscow State University, working at the Mathematical Institute of Academy of Sciences. In 1941, he became a full professor. Once he has a DSc, he became a full professor at Moscow State University. He held this position for the next 50 years. So from 41 up to 91, he was a full professor at Moscow State University. This Mathematical Institute of Academy of Sciences is a bit closer to the Academy of Sciences. So this is the Mathematical Institute of Academy of Sciences. Yes, I have visited, my friend was working over there. I have visited this Academy of Sciences a few years back, in 2013. Gelfan started a school by correspondence in the evening time, a school by correspondence for high school students at Moscow State University. In Moscow State University, he started a correspondence for high school students, founded by Gelfan in 1964, and commonly known as Gelfan School. The education in Gelfan School was free. You don't have to pay anything. Of course, at that time, education in Russia was free. The staff of the Gelfan School consisted of 6 to 10 teachers and program coordinators, and about the same number of administrative assistants, because it was a correspondence school. There should be a lot of correspondence, a lot of administrative work. To be admitted to Gelfan School, a student needed to pass a written entry examination. The first class of 1964 consists of 1,472 students, selected from about more than 6,000 applicants. The total number of students of the school over its 46 years of work were exceeded. A huge amount. So this is evening school by correspondence, not a regular school. School for mathematics. Today's Gelfan School is alive and well. It is now called an open lycée. Essay, that's more. So, this Gelfan was very instrumental in Olympiad, in teaching the Olympiad. So he used to, that's why he opened this corresponding school for the students, school students. He was explaining solution to Olympiad photo of 1968, explaining geometry to 8th grade, photo also from 1968. And he has authored very many books for that level, for school level. So this one on the left, is function and graphic, the trigonometry, method of coordinates. This is also English translation, trigonometry, that's what you can say, algebra. So all these 5 books I have shown is in my library. I have this photograph is from my library. Now let's continue with this short biography. 1942, married to Yakovlevna Safrino. They had 2 sons, Sergei and Vladimir. In 1940, organized a mathematics seminar at Moscow State University. The seminar took place every Monday until 1990. It's called Gelfan's Mathematics Seminar. 1953, he headed the department at the Institute of Applied Mathematics in the Academy of Sciences. And in 1958, became interested in biology and medicine. So, though he was pure mathematician, he got a lot of interest in biology and medicine, more with application of mathematics in biological and medical sciences. This is Gelfan's Mathematics Seminar, Moscow State University. When I was doing PhD in 1980, so my supervisor said that you are already faculty at the University in Nepal. So if you want to be a good faculty and good professor, you should attend Gelfan's Mathematics Seminar. Though my university was People's University, he advised me to go every Monday to attend this Gelfan seminar. I attended this Gelfan seminar in 82, 83 for the whole year of during my PhD work, PhD research work. So that this is the room where you used to have this weekly seminar. So this is one of the time when you were having a seminar. So maybe the greatest mathematics seminar in the history of mechanical mathematics faculty of Moscow University. So the faculty in this Moscow University was called mechanical mathematical faculty, not pure only faculty. Because mechanical is more related to mathematics. Even my PhD was in more related to mechanics. It was in the Department of Theoretical Mechanics. So to Gelfan seminar notes, there was a mathematician called Mikhail Shubin. From 1964 to 1989, he was taking the notes of all Gelfan seminars. So most photo during the seminar. So with our back here shown before the Monday night seminar. What he used to do is after every at the end of every seminar, he will say that next time such a mathematician will deliver the seminar on this topic. And before the seminar starts, he was talking with a person who has come to deliver the seminar on a Monday. So, and sometimes, and I remember very vividly, so one time he said that next seminar will be on this topic, and the presenters are generally, they come from different cities, not only from Moscow, they come from different cities to deliver this seminar, their seminar. And he will say that next time you have this seminar. One time he told that this is the topic of seminar, and before the start of seminar, he asked the audience, participants of the seminar, what do you know about this topic? So everybody was silent. Then he scolded. Hence I say that next time we have this seminar, you should look at it. But at the time there was the internet and all these things. You have to go to the library and so on. That was a very difficult task. But anyway, so he was very strong and rigid in the seminar. All the seminars we used to start promptly in time and complete promptly in time. It was so popular that mathematicians from different cities, they come and deliver, and there is a queue to deliver a seminar in this Gelfan seminar. I attended this Gelfan seminar for 1 year in 82, 83, and no short biography. And 61, organized interdisciplinary department in collaboration with director of the Institute of Biology. Now he has taken interest in physics, biology, and medicine. In 1796, his department became known as Laboratory of Mathematical Methods in Biology at the Research Institute of Physical Chemical Biology. So in 1961, he started a biological seminar which brought together physiologists, cell biologists, and biochemists. So he was slowly moving from pure mathematics to applied mathematics, I can say like that. And his first wife died, and he married in 1979 Tatiana Alexeyevskaya. They had a daughter, Tanya, and the daughter was born at a very late age of Gelfan at the age of 68. This photo of Tatiana Alexeyevna, and they had a child, a small Natasha, grandchildren. In 1970, he received an honorary doctoral degree from Oxford University. So he went to attend this Oxford University to get the honorary doctoral degree. In 1990, was a visiting professor at Harvard University and at MIT in US. From 90, the Russians has changed from that communist country, socialist country, to a more liberal type of country. And so they could move very easily. And so in 1990, he was a visiting professor at Harvard University and at MIT. This is a lecturing at MIT in 1989. In 1990, moved to the US, lived in New Jersey, worked as a distinguished professor at the Department of Mathematics at Rutgers University in Piscataway. So he settled in the US, in New Jersey. Okay. Now let's look at Gelfan's work. How to describe all the Gelfan's achievements in mathematics. He left his unique and powerful imprint everywhere, excluding probably mathematical logic. So he didn't work on mathematical logic. He worked on all disciplines of mathematics. He left a number of papers in biology, physiology, medicine, and other fields, not only mathematics. So he had papers on biology, physiology, medicine, and other fields. In 2003, it was his 90th birthday. An international conference was held in Cambridge, Massachusetts, not in UK, on August 31st to September 4th, 2003, in honor of the 90th birthday of Israel. Israel mathematics is fun. We're talking at the 90th birthday conference. And in the New York Times, there was an article about Gelfan in person, an equation for success. So one of the on the eve of his 19th birthday, Gelfan reflected on the essence of mathematical achievements. This is not only about aptitude. He said, sitting in his cozy office in the Bush campus of Rogers University, where he spent his last days of life in his way. It is about appetite. It is not only about aptitude, it is about appetite. So Dr. Gelfan is a distinguished visiting professor in mathematics and widely considered to be among the greatest mathematicians of the 20th century, as demonstrated miraculous aptitude for mathematics and more. For more than 70 years, he has conducted pioneering research in every branch of mathematics, collaborated with colleagues around the world, guided a doctoral thesis of countless students, and established corresponding schools in the Soviet Union and in the United States also. He continued at the same corresponding school and also seminar. This is an international conference on the unit of mathematics to be held in Cambridge, Massachusetts. This is advertised for his 19th birthday. What Gelfan told during the 19th birthday celebration dinner, after there was dinner, it is a real pleasure to see all of you. I will ask many questions. I'll try to answer some of them. Let's look at his answer. The first question is, why at my age I can work in mathematics? So he was already 90 years. I don't know when we will be there. So the first question is, why at my age I can work in mathematics? The second question is, what we must do in mathematics? And third question was, what is the future of mathematics? Now let's to catch the admission. So in 2009, passed away at the age of 96 on October 5, 2009 in the Robert Woods Johnson Hospital in New Brunswick, New Jersey. Israel died in the same Los Angeles Times as to report that Israel Gelfan died in 1996 in Russian mathematics. Israel Gelfan, the Russian mathematician whose research led to mathematical framework for the imaging abilities of the MRI in medicine, and CT scanner who did crucial work in a most of more esoteric fields like Monday at Robert Woods Johnson University in from the newspaper. During a century when mathematics were becoming very more specialized, focusing on narrow and often exotic areas of research, Gelfand became a legend as a generalized generalist who made connections in more than a dozen areas. His work, the field known as representation theory, was an underpinning of quantum physics, which is a basic for quantum. Awards include, so he was member of Moscow State Active, the State Prize of the USSR, the Lenin Prize, the Wolf Foundation Prize in Mathematics, Winger Medal, the Kyoto Prize, MacArthur Foundation Fellowship, the State Award of the Russian Federation, the Leroy Steele Prize for Lifetime Achievement from American Mathematics Society. He was elected a member of several academic recipients over here. Gelfand was a corresponding member of the US Academy of Sciences since 1953 and was elected as a full member in 1984. So he received honorary degree from so many countries: England, USA, France, Sweden, US, Italy, Japan, of course Russia, and India. Let's look at his publication. Gelfand publication year-wise, 1941 to 2003. From 1991 to 1949, in 10 years, he published 29 only. 1950 to 59, 76. 1962, 1969, 83, 1972, 77, 81, 1982, 89, 1990 to 99, 96, 2000 to 2003, 10. And total he has 445 publications. Not as large as Euler, but now it was a time when you don't have many things to discover. In Euler's time, everything what you discover is new. But by 2000, most of the thing in the 20th century, most of the thing has discovered. So to discover and writing new articles is not so easy. Even then, he has 445 articles published between 1941 and some saying by Israel Gelfand. Mathematics for me is a universal and adequate language of science, and it is an example of how people of different cultures and backgrounds can communicate and work together. This is extremely important in our times. This is from Gelfand's acceptance letter to American Mathematics Society for the Leroy Steele Prize. More on saying by Israel Gelfand. Mathematics is a part of human culture, and professionals must understand the way of thinking. From Gelfand interview for the Highland Park April in 1992. In our century of rapid changes, it is impossible to know everything. The goal is to learn how to learn. From the DCPM elections 1994, people or strengths do not have shortcomings, only uniqueness. The goal of a good teacher is to turn this uniqueness into advantage. Often repeated by Gelfand. Explain this to me on a simple example. Difficult example I'll be able to do on my own. Written down by T.V. Gelfand. Tatiana Gelfand is wife in 1994. Do not be afraid to ask simple questions and receive simple answers to them. Written by other mathematicians. In an area of knowledge, the number of ideas is limited. Everything else is a variation on the theme. In mathematics, the number of ideas is not large. Everything that is achieved is obtained from the basic of a fundamental concepts, which are applied with some degrees of variation. Mastering these basic concepts in our field of mathematics helps to distinguish and use them in other fields. From the introduction to geometry book, thus co-authored by Tatiana Gelfand, submitted for publication. It is still not published at this time. I am an optimistic in the battle between good and bad. The good cannot lose from the interview for right data. So these are some photos. Gelfand, which is my grand daughter. Now coming almost to the end. Gelfan Secretary from 1932 to 1949. So this is an announcement about the Gelfan centenary to be held in Moscow from July 22 to 25 to 29 in Moscow by the Academy. So I attended this Gelfan Academy, and I was given a small piece of time to talk about Gelfan and his, my attendance of his Gelfan seminar during my PhD. Over here, this is his daughter Tatiana, son, two sons, Sergei and Vladimir. Sergei is a member in the American Mathematical Society publications. He's the editor, one of the editor in the American Mathematical Society publications. So I could meet his daughter and both of his sons, Sergei and Vladimir, during my attendance in centenary celebration by Russian Academy of Sciences. And immediately after that, in July, in August, a Gelfan seminar was also here in MIT. So, organized by the MIT Harvard University. I was invited here by the president of the American Mathematics Society, and I attended this centenary, Gelfan centenary at MIT also. So this is the president of the American Mathematics Society, David Bacon. So I gave the present to him on behalf of the Nepal Mathematics Society, and at the time I met those Abel laureates, Isaac Forward and Peter Stefan here. And this is the second wife, Tatiana, and this is the daughter, also named Tatiana. Spelling is a bit different. This is Tatiana, this is Tatiana. Russian sounding over here. And my wife was here, so the mother and daughter, they look alike. It's 28 to 30, you might think. Okay. Now, today is the 8th seminar. So when it is in the 8th seminar, I take it as the middle of our presentation. And so, since it is presentation, I have a small story for you. Okay? Small story for you. The story is the story of Narayan and Narayan. I hope that many of you may have heard about this story. So, म चाहिँ नेपालमा हुन्छ ओके कथा चाहिँ नेपालमा हुन्छ यो नारायण र नारदको चाहिँ कथा बिचमा मैले ल्याएको छु एक दिन चाहिँ नारदले नारायण कहाँ गएर के बकवास गर्यो भने हजुर तपाईँको अनन्य भक्ति संसारमा त्रिलोकमा म बाहेक अरू पनि छैन भनेर नारायणलाई चाहिँ एकदम फुर्ती लगाउनु चाहिँ नारदको कामै थियो ताले बजाएर ट्याङ्गाइ गरेर नारायण कहाँ गएर किन तिमी म त हरेक छिन पल पलमा एक तारोमा चाहिँ नारायण नारायण जपेर म त्रिलोकमा पुगिरहेको हुन्छु तर हजुरको अनन्य भक्त यो म बाहेक अरू को पनि हुन सक्दैन भनेर फुर्ती लगाएर नारायण कहाँ गएर नारायणले एकचोटि चोक बोलेर होइन नारद मेरो अनन्य भक्ति तिमी हुन सक्दैन मेरो अनन्य भक्ति अर्कै छ अर्कै व्यक्ति छ तिमी होइन नारदले रिस उठ्ने भइहाल्यो गुणगान गरेर गएको है नारायणले चाहिँ होइन भनेको भारत चलिहाल्यो होइन त्यो हुनै सक्दैन म बाहेक अरू कसैले पल पलमा चाहिँ नारायण जप्ने मान्छे नारायणको गुणगान मान्छे त्यो लोकमा केही पनि हुन सक्दैन नारायण भगवान्ले चाहिँ गर्दैन भने जित त्यो पनि नारायण चाहिँ अब चिकित गर्नुपर्ने मान्छे लाग्दै लागेन नारायण भगवान्ले के भन्नुभयो भने ल तिमी चाहिँ नि 24 घन्टा मसँग बस्नुपर्छ मैले तिमीलाई चाहिँ नि मेरो अनन्य भक्ति को भनेर तिमीलाई चाहिँ देखाउँछु भनेर भन्नु सहमतिमा चाहिँ ज्ञान सबैले आकाशबाट स्वर्गबाट पृथ्वीमा सोतल देखाएर त्यो मुख भेटाएको एकजना मान्छे चाहिँ फेरि त्यो किसान त्यो हो मेरो भन्ने नै भक्त भनेर मन ऊ त भर्खर मुखले अलिक केही गरेकै छैन अनि मुख सुख गएपछि अनि यसो आकाश हेरेर नारायण भनेर यस्तो गरेपछि त्यसै गरी अनि अलिकति नास्ता सास्ता गरेर आफ्नो चाहिँ खेतमा चाहिने सक्ने खेतीको बोकेर हिँडे र त्यहाँ पुगेपछि त्यहाँ नपुगेपछि आफ्नो समाचार मिलाएपछि नारायण भनेर त्यो चोकेर काम गर्न थाल्यो मस्तसँग चाहिँ खेत जोत्ने यताउता गर्ने सबै काम गरेपछि श्रीमतीले खाना ल्यायो श्रीमतीले त्यहाँ खाना ल्याएपछि अनि खाना साथै मिलाएपछि उसले हात साथ लिएर अनि नारायण भन्यो अनि खान थालेर फेरि हात साथमा फेरि नारायण भने फेरि काममा लायो श्रीमती फर्के त्यसपछि चाहिँ कामसाम सिकाएपछि फेरि घरमा गएँ तपाईँ सुगर गरेँ मैले हात पनि केही गरेपछि फेरि रातिको खाना खानु पर्यो खाना गरी नारायण पनि अलिक मजासँग त्यस्तो काम गरेर आएको मरासन खाएर एकदिन पनि सुतिहाल्यो सुत्न अगाडि नारायण भन्यो उसको निराइहाल्यो अनि भोलि बिहान चाहिँ भने चाहिँ नारायणले हजुर त्यो कसरी भक्त हुन्छ उसले 4 चोटि भन्दा 5 चोटि भन्दा बढी नारायण नै तपाईँको छैन म त पट्याउँदैन भनेर नारायणले जिद्दी गरे नारायण भगवान्ले तिमी मैले प्रत्यक्ष रूपमा देखाउँदाखेरि पनि तिमीले पट्याएन हो अब तिमीलाई म प्रमाणित गरेर देखाउँछु प्रमाणित गरेपछि त तिमी चाहिँ विश्वास गर्नुपर्छ नि प्रमाणै गरेर मैले देखाउँछु प्रमाण गऱ्यो भने त मैले म हारिहाल्छु नि हुन्छ हारोस् मरेस् हारिहाल्छु हुन्छ म प्रमाणित हुन सक्यो भने म विश्वास गरौँ नारायण भगवान्ले नारायण त्यो पर चाहिँ कुलोमा दुध उमालिरहेको छ 1 कटोरा दुध यहाँदेखि यहाँ लिएर आऊ तर 1 थोपा पनि तिमीले पकाउनु पाइँदैन पकायो भने म श्राप छु तिमीलाई हस् भगवान् भनेर 1 तार राखेर भान्सामा गए 1 कटोरा दुध अगाडि राखेर लिएर नारायण कहाँ पुग्यो ल भगवान् आउँछु यताउता गऱ्यो भने पुगिहाल्छ श्राप पाइहाल्छ बिस्तारै बिस्तारै आयो बिस्तारै दुई हातले कटोरमा नारायणले चलायो ल भगवान् मैले गरिहालेँ यो त ठुलो काम हो तिमीले त्यहाँदेखि यहाँसम्म दुध ल्याउँदाखेरि नारायणको जप कतिचोटि गऱ्यो नारायणको जप गऱ्यो भने मेरो दुध पुगिहाल्छ मैले सत्ता पाउँछु नि भनेर चाहिँ नारायणले त्यो किसानले आफ्नो काम गर्ने बेलामा नारायणको जप गर्यो भने त उसको कामै ठालुङ हुन्छ काम गर्ने मान्छेलाई काम गर्ने बेलामा दायाँ बायाँको के पनि चाहिँ वास्ता गर्नु हुँदैन आफ्नो काममा लगनसँग गर्नुपर्छ त्यो किसानले खेती गरेर सारा संसारलाई जीवन दान दिइरहेको छ खाना दिएर तिमीले 1 तारा बजाएर लाखौँ चोटि नारायण भनेर कसलाई के दिएको तिमीले के पनि दिएको छैन जसले के दिएको छैन कन्ट्रिब्युट गरेको छैन तिमी कसरी ठुलो हुन सक्छौ त्यस कारण मेरो लागि यो त्रिलोकमा सबभन्दा मेरो अनन्य भक्त त्यो किसान हो भनेपछि नारायण चाहिँ अब लाजवाब भएर चाहिँ नारायणले क्षमा पाउँ भनेर चाहिँ दर्शन गरे भनेपछि यो कथा यस्तो नारायण हामीले पनि काम गर्ने बेलामा दायाँ बायाँ हौजाल आयो कि आफ्नो सिनमा आयो कि यताउता चाहिँ आफ्नो डिस्ट्र्याक्सन गर्ने होइन जुन कुरा छ त्यसमा ध्यान दिनुपर्छ भन्ने यो कथाको चाहिँ निचोड हो ल कथा यतै भयो अब अन्तमा जब चाहिँ मेरो सेमिनारको अन्त 15औँ पनि फेरि एउटा त्यस्तै खालको कहानी आउँछ भनेर आजलाई सकियो अर्को सेमिनार चाहिँ 1 हप्तापछि डिसेम्बर 17 तारिकमा भइहाल्छ त्यस हुन्छ मेरो सिरिज म्याथमेटिक्स एजेसमा गइरहेको छु अब 2 जना एक्स्ट्रा अर्डिनरी म्याथमेटिसियनको आज लाइफ हिस्ट्री हेरेँ जस्ता म्याथमेटिसियन संसारमा चाहिँ 18औँ शताब्दी र 20औँ शताब्दीमा चाहिँ भएका 2 जना गेल्फानको अब अर्को पालो चाहिँ हाम्रो फेरि म्याथमेटिक्समा फर्केर अल्जेब्राइकल ट्रिटिज भनेर अल्जेब्राको विषयमा डिप्लोमेको विषयमा म अर्को सेमिनारमा भन्नेछु ल आजै सकियो एनी क्वेसन्स एनी इन्ट्रेस्टिङ क्वेसन्स एन्ड के छ भने आई एम रेडी टु डायलग गर्न सकिन्छ दिपक
सर मजाको कथा सुनाउनु भयो त आज त
राम्रो छ जीवन पनि राम्रै होला इन्सपायरिङ जीवन त हाम्रो कहाँ हुन्छ
होइन त्यो उसको त सुनेकै रहेछ यो पछिल्लो चाहिँ इरफानको त कति पनि सुनेर हुन्छ ओइलरको त अब अलिअलि आफै पनि पढाउँदाखेरि रिभ्यू पनि गरियो
आइहाल्छ होइन त्यस कारण आउने भइहाल्छ गेल्फानको पनि आउनु एक दुईवटा एडभान्स म्याथमेटिक्स पढ्ने रिलेटिभ म्याथमेटिक्स पढेको मात्रै आउनु अरू कल्पना गरौँ
इन्स्पायरिङ त्यो त इन्स्पायरिङ रहेछ स्टोरी चाहिँ उसको चाहिँ
जस्तो सेमिनार मैले एक वर्ष एटेन्ड गरेँ नि त्यो त भन्नै पर्यो मैले
होइन सरले खत्रै अपर्च्युनिटीहरू लिनु भएको छ
त्यो भएर चाहिँ मसँग उहाँको ठुलो भोलुमको किताबै छ त्यो गेल्फान सेमिनारमा जाँदाखेरि सेन्टिनेरीमा जाँदाखेरि मलाई प्रेजेन्ट गरेको छ यत्रो ठुलो भोलुमको किताबै छ त्यस कारण मैले त्यहाँबाट फोटो निकालेको
होइन राम्रो गर्नुभएछ त्यो अहिले हामीलाई हेर्दाखेरि पनि एक किसिमको चाहिँ नि सरको अचिभमेन्ट अब आई मिन ठुलो मान्छेहरूसँग सँगै छेउमा बस्न पाउनु पनि ठुलो अचिभमेन्ट मान्नुपर्छ त्यो धेरै धेरै राम्रो लाग्यो त्यो स्पेसली ओइलरको त्यो प्रेजेन्टेसन बसल प्रब्लम कि बेसल प्रब्लम सर त्यो प्रब्लम चाहिँ त्यही अन्डर ग्रेजुएट म्याथमेटिक्स पढाउँदाखेरि म आफै पनि युज गरेको थिएँ कि त्यो एउटा यो ट्रायम्स भन्ने प्रोजेक्ट चाहिँ हिस्ट्री अफ म्याथमेटिक्समा काम गर्ने तिनीहरूले चाहिँ कसरी गर्छ भने त्यो एकदम लो लेभलमा लगेर मतलब एकदम पोलिनोमियलबाट इन्ट्रोडक्सन दिएर फ्याक्टराइजेसन सिकाएर अनि कसरी चाहिँ त्यो ओइलरले प्रुभ गर्दाखेरि त्यो मतलब म्याथमेटिकल टुल्स युज गरेर चाहिँ उसले लिएर आयो त्यो भन्ने कुरालाई एकदम लो लेभलमा कम्युनिकेट गरेको छ हो त्यो गरेको त्यही भएर सरको त्यो प्रेजेन्टेसन त्यो पार्ट चाहिँ आई मिन आई फिल लाइक इट्स भेरी रिफ्रेसिङ मजा आयो अनि पछिको त त्यो नयाँ इन्फर्मेसन भइहाल्यो भेरी इन्सपायरिङ 96 इयर्स ओल्ड है त्यत्रो पेपर पब्लिस गरेर राम्रो लाग्यो अनि नारदको कथा सुन्दै गर्दा चाहिँ के लागेको थियो भने यता हाम्रो नयराज पन्त गुरुको प्राय किताबहरूको अगाडि चाहिँ त्यही संस्कृतमा एउटा श्लोक हुन्छ अनि त्यसमा चाहिँ विद्वानले गर्ने आफ्नो काम गर्ने हो अनि कुरा काट्नेले यो भएन त्यो भएन भनेर भनिरहन्छन् ती भन्नेहरू मूर्ख हुन् श्लोक हुन्छ क्या नारदको स्टोरी हो अनि नयराज पन्तसँग कनेक्सन भयो जस्तो लाग्यो हो आखिर वास्तवमा यो भएन त्यो भएन भन्न सजिलो छ तर आफैले परि गरेर पुर्याउन त गाह्रो छ त्यही त धन्यवाद सरलाई यो जारी राख्नु भएको छ अब खुसी लाग्यो exactly this is very fun
anybody
सरको टक सुने र मलाई अलिकति बोल्न मन लाग्यो फेरि हजुर त्यो एकदम इन्स्पायरिङ छ कि यो यङ्गर जेनेरेसन भनौँ न यङ म्याथमेटिक्स पढिरहेकाहरू रिसर्च गर्ने एस्पाइरेन्टहरूलाई चाहिँ एकदमै मोटिभेसनल टक छ जस्तो 13मा चाहिँ युनिभर्सिटी जोइन गर्ने 19मा चाहिँ पिएचडी होल्डर भनेको त यो त इन्क्रेडिबल कन्ट्रिब्युसन हो म्याथमेटिक्समा अनि मैले यसो सरको त्यो म्याथमेटिकल टर्म्सहरू म्याथमेटिकल फर्मुलिजहरू जो कनेक्सन गरेर सरले दिनुभएको छ त्यहाँ त के कथा पनि आएको थियो अघि दिपकजीले पनि भनिसक्नु भएको छ Why not about Nepalese mathematicians such as senior professors? They are the treasure of hidden treasure भन्नु पर्यो अब त्यसलाई चाहिँ अलिकति फ्ल्यास आउट गर्दा राम्रो हुन्छ कि हामीले पनि हाम्रो नेप्लिज हिस्ट्रीमा म्याथमेटिसियन्सहरूको यसरी खोजी गर्ने उहाँहरूको कन्ट्रिब्युसनले यो गरेको थियो भनेर अनि अलिकति इन्स्पायर्ड भएर त्यही विषयमा चाहिँ खोज नीति गरेर एउटा रिसर्च गर्दा पनि राम्रो हुन्छ कि भन्ने मैले त एउटा आइडिया मात्रै सेयर गरेको आफूले त गरेको होइन कि तर मैले आइडिया चाहिँ यसरी गर्दा देयर आर मेनी म्याथमेटिसियन्स हु आर द नेप्लिज के अरे यो नेपालको लागि एउटा एसेट्सहरू छन् जस्तो लाग्यो खोजी नीति गर्नुपर्ने जस्तो लाग्यो त्यसमा चाहिँ अब सरहरू पनि पढ्नुहुन्छ भन्ने लाग्यो मलाई किनकि सरको यत्रो कलेक्सन यत्रो नलेज
अहिले मेरो चाहिँ के छ भने यो मसँग जुन यो जुन चारवटा फरमको म्याथमेटिक्स थ्रु आउट एजेस भन्नेबाट यो सेमिनार गरिरहेको है
हजुर
त्यो सम्बन्धमा रिलेटेड सब्जेक्ट हो अहिले त्यो सेमिनार सिरिज गरिरहेको पछि चाहिँ अब नेपालको अथवा चाहिँ एसियन भनौँ न एसियन म्याथमेटिक्सबाट इन्डियन चाइनिज र यता सायद जापानिज पनि होला यता कुराको म्याथमेटिक्स डिप्लोमाको फेरि अर्को किसिमको छ नि एउटा सेमिनार गर्न सकिन्छ
त्यस्तो खालको
गरे पनि हुन्छ
त्यस्तो खालको रिसर्च रिपोर्ट्सहरू
5-6 जनाको टिम भने मैले यसको इन्डियाको खोजेर प्रेजेन्ट गर्छु मैले चाइनाको खोजेर प्रेजेन्ट गर्छु भनेर यो आफूलाई चाहिँ नि ग्रो गराउने चाहिँ पायो भने सबै मैले माथि तपाईँले भन्नु भन्दा छ तपाईँले पनि खोजेर हामीले भन्नुहोस् न
त्यो चाहिँ हाम्रो हिस्ट्री अफ म्याथमेटिक्स पढाइन्छ के अरे कुनै कुनै डिपार्टमेन्टहरूमा त्यो डिपार्टमेन्टको स्टुडेन्ट्सहरूलाई चाहिँ हामीले इन्करेज गर्न सक्ने रहेछ सर एउटा आइडिया सेयर गरिहाल्नु सर
म्याडमले ल्याइहाल्नुभयो यहाँ अलिकति थप्नु पर्यो अलिअलि आफूले त्यता काम गर्ने भएर
हजुर
त्यो एकदमै राम्रो आइडिया हो आई थिङ्क एउटा प्रब्लम चाहिँ के हो भने हाम्रो त्यो हिस्टोरिकल सोर्सेसहरू चाहिँ खासै जोगाइएको छैन जस्तो हामीलाई यसले यो किताब लेख्यो यसले यतिखेर यो गर्यो भन्ने चाहिँ लगभग इन्फर्मेसनहरू पछिल्लो समय शङ्कराचार्य सरहरू लगायतले अलिअलि लेखेर त्यो इन्फर्मेसनहरू एभाइलेबल भए पनि आफैमा त्यो सोर्स बुक खोज्न जाँदा चाहिँ त्यो लगभग तपाईँको नभेटिने अवस्थामा छ क्या पुरानो अब नयाँ केसमा अब जस्तो सरहरूले अहिले म्याथमेटिक्समा काम गरिरहनु भएकोहरूको बायोग्राफिकल इन्फर्मेसनलाई पनि इन्ट्याक्ट राख्ने भन्ने कुरा द्याट क्यान बी डन तर अब दुईटा पर्सपेक्टिभ हुन्छ त्यसमा चाहिँ अब यसमा एउटा चाहिँ एक्चुअल म्याथमेटिक्स के गरिराखेको भन्ने कुरालाई खोज्नु पर्यो अनि त्यो एक्चुअल म्याथमेटिक्सको बारेमा अब जसले काम गरेको छ उसैलाई नै थाहा हुन्छ धेरै कुरा चाहिँ अब बायोग्राफिकल इन्फर्मेसनहरू राख्न सकिन्छ त्यही भएर यो चाहिँ कस्तो कोलाबोरेटिभ वर्क भयो भने थोरै चाहिँ जस्तो म्याथमेटिक्स गरेको फिल्डको टिजर अब वाट एक्ज्याक्टली इज कन्ट्रिब्युटिङ सी इज कन्ट्रिब्युटिङ भन्ने कुरा अनि त्यसपछि हाउ हिज लाइफ वेन्ट इन्टु म्याथमेटिक्स भन्ने हिसाबको चाहिँ डकुमेन्टेसन गर्न सकियो भने इभन ब्रिफली गर्न सकियो भने त्यो चाहिँ तपाईँको फ्युचरमा मान्छेले फेरि त्यहीबाट उठाउँछ नि आखिरी अलिकति थोरै सुरु गर्ने न हो जसले गरे पनि होइन त्यो चाहिँ गर्न सकिन्छ हो नि रिसोर्सेस हुन्छ त्यो चाहिँ गर्न पर्छ गर्न सकिन्छ तर समस्या के हो भने एक त अब पुरानो खालको हेर्दाखेरि रिसोर्सेसहरू चाहिँ खासै त्यति छैन मलाई चाहिँ के भयो फिडब्याक आए जस्तो भयो नि
होइन एकदम ठिक हो यस्तो खालको डिस्कोर्स पनि हुनुपर्छ हामीले म्याथमेटिक्स किन पपुलराइज भएन रिसर्च फिल्डमा चाहिँ हामी किन धेरै जान सकिरहेको छैनौँ रिसर्च गरिराखेको पनि पर्टिकुलर फिल्डमा मात्रै पर्टिकुलर एक्सपर्टिजहरू मात्रै भएर पनि भएन नि हाम्रो नेप्लिज कन्टेक्स्टलाई हेऱ्यो भने त म्याथमेटिक्सको लेभल म्याथमेटिक्सको नलेज हामी कति रिसर्च फिल्डमा लागिरहेछौँ र कति कन्ट्रिब्युसन गरिरहेछौँ भन्ने त हामी थोरै नै छौँ जस्तो लाग्छ मैले त्यो पर्सपेक्टिभबाट मात्रै भनेको हो होइन तर यसरी गर्न सक्यो र हामीले यङ्गर जसले चाहिँ रिसर्च वर्क गर्छ त्यस्तोलाई पनि प्रायोरिटी दियो भने त्यो फिल्डमा त्यसले चाहिँ डकुमेन्टेसन गर्छ रिसर्च रिपोर्ट्सहरू अब त्यो कस्तो आस्पेक्टमा गर्ने कुन मेथडले गर्ने होइन त्यसको मेथोडोलोजी के हुने भन्ने कुरा त आफ्नो होला होइन तर त्यसले दिएको रिसर्च रिपोर्टहरू नेप्लिज म्याथमेटिक्स र म्याथमेटिसियन्सहरूको बारेमा गऱ्यो भने द्याट क्यान बी द बिग एसेट्स फर्दर रिसर्च के फर्दर आउने विद्यार्थीहरूको लागि त्यो रिसर्चफुल हुनसक्छ र नेप्लिज म्याथमेटिक्स यस्तो छ भनेर पछि त्यो हिस्ट्री चाहिँ रिसर्चफुल हिस्ट्री बन्न सक्छ भन्ने मेरो हो एकदम राम्रो लाग्यो यो डिस्कोर्स चाहिँ तपाईँले गर्नुभएको
आफ्नो थेसिस चाहिँ म्याथमेटिक्स नेपालको म्याथमेटिसियनको बायोग्राफी राम्रोसँग खोजेर राख्यो भने त्यो राम्रै थेसिस हुन्छ
हो त्यस्तोमा पनि किन नलगाउने हामीले के भन्नुभयो जस्तो हाम्रो त अब मैले त बिए बिएससी मात्रै पढाउने भएको भएर उनीहरूको प्रोजेक्ट वर्क छ अब प्योर म्याथमेटिक्स भनेर हामी प्रोजेक्ट वर्क गराउँछौँ तर त्यसमा पनि रिसर्च मेथोडोलोजीहरू गर्ने छ तर थेसिस लेखाउने त मास्टर्स लेभलमा हो तर मास्टर लेभलमा कहाँ लेखाउने भन्दाखेरि कि त सेन्ट्रल डिपार्टमेन्ट म्याथमेटिक्स कि सेन्ट्रल डिपार्टमेन्ट म्याथमेटिक्स एजुकेसन कि किशोरमा लेखाउनु पर्यो होइन अब त्यही हो र म्याथमेटिक्समा जसरी सरहरू लागिराख्नु भएको छ त्यसलाई चाहिँ हामीले
एउटा आइडिया के हुन सक्छ भने जस्तो मास्टर्समा मात्रै नै लेखाउनु पर्छ भन्ने चाहिँ छैन अब अन्डर ग्रेजुएट रिसर्चहरू जति पनि चलिरहेकै छ मलाई लाग्छ एउटा गुड स्टार्टिङ पोइन्ट त्यो पनि हुन सक्छ है धना म्याम जस्तो बायोग्राफिकल इन्फर्मेसन इन्क्लुडेड अनि अलिअलि तपाईँको जस्तो प्योर म्याथमै गराउनुहुन्छ होला तपाईँहरूले अन्डर ग्रेजुएट प्रोजेक्ट गर्दाखेरि त्यसमा चाहिँ सामान्य मतलब अलिकति चाहिँ प्योर म्याथ पनि राख्ने तर मोर चाहिँ बायोग्राफिकल टाइपको हिस्ट्री फ्लेभर
मिक्स
आउने टाइपको त्यो खालको एक्ज्याक्टली
अहिले चाहिँ त्यो मिक्स मेथड जस्तो कि भनौँ न एउटा मिक्स मेथड जस्तो
त्यो चाहिँ गर्न सकिन्छ जस्तो लाग्छ
हजुर
अहिले त पछिल्लो समय त यो प्रोजेक्ट राइटिङ इन अन्डर ग्रेजुएट म्याथमेटिक्स भनेर कता दुर्गा सरहरू सन्तोष सरहरू कहिले प्रोजेक्ट गर्दै हुनुहुन्थ्यो कहिले अलि अगाडि जस्तो लाग्छ
हो त्यो मेतिर भएको थियो अप्रिल कि कहिले भएको थियो
हो अनि फेरि अब जस्तो हामीले त्यो प्योर म्याथमा गर्ने भने पनि अब पुरानो एक किसिमले लगभग कपी क्याट गरेर बुझ्ने खोजे जस्तो मात्रै देखिएको छ प्रोजेक्टको स्थिति चाहिँ रियल कन्ट्रिब्युसन गर्न सकिएको छैन
एक्ज्याक्टली
बरु अहिले म्याडमले भन्नुभएकोमा ल्याउन सकियो भनेदेखि त एटलिस्ट त्यो खोज गर्ने पनि बानी हुन्छ
हाम्रो कन्टेक्चुअल पनि मिल्छ कि मैले एउटा अनुभव मेरो सेयर के गरेको भने इरानको साथी भेटेँ होइन भियतनामको साथी भेटेँ म्यानमारको पनि भेटेँ तर तिनीहरूको लिनियर अल्जेब्राको बुक आफ्नै ल्याङ्ग्वेजमा कि हामीले यहाँ पढ्थ्यौँ नि आरएमएस सरको राममान सरको बुकहरू
हजुर हजुर
तर उहाँहरूको आफ्नै ल्याङ्ग्वेजमा लेखेको बुक के इभन थाइल्यान्डको साथीहरूले पनि आफ्नो ल्याङ्ग्वेजमै पढाइरहेको हुन्छ प्रेजेन्टेसन पुरै उनीहरूको स्क्रिप्ट हुन्छ कि भनेपछि त्यो हामीले लोकलाइज गर्न सक्यो त्यही अनुसार चाहिँ हामीले म्याथमेटिक्सको डेभलप गर्दै गयो भने पनि हामी वान स्टेप केही गर्न सकिन्छ कि भन्ने मात्रै यो म्याथमेटिक्सको पपुलराइजेसन हामीले जुन एनसिएफ 2075 को बारेमा हामी जति पनि लडाइँ गर्दै गयौँ होइन म्याथलाई यसरी गर्नुपर्छ यसरी पपुलराइज गर्नुपर्छ भनेर त्यो पनि एउटा हुन्छ कि भन्ने हो
फेरि त्यो एनसिएफमै पनि तपाईँको त्यो हिस्ट्री अफ म्याथमेटिक्सलाई त उस गरौँ भने प्रमोट गरौँ भनेर भनेको छ अब पढाउने सवालको पनि हिस्ट्री युज गरौँ भन्ने कुराहरू पनि ल्याएकै छ त्यो अब त्यो हो होइन यो सरको प्रेजेन्टेसनले यति डिस्कोर्स सुरु गराएको छ अब यसलाई मेटेरियलाइज गर्ने तपाईँ हामी नै वास्तवमा चाहिँ
सो ग्रेटफुल फर दिस कि यसरी बोल्नु पाउँदा डिस्कोर्स गर्नु पाउँदा होइन एउटा सेयर गर्न पाउँदा पनि अलि आफूलाई के अरे रिफ्रेस भएको जस्तो होइन एउटा इन्ट्याक्ट भएको जस्तो म्याथमेटिक्ससँग हजुर सर
त्यो पनि सर अर्को चाहिँ अहिले धन म्यामकै मैले कुरालाई सपोर्ट गर्दै चाहिँ अलि अब यो डिस्कोर्स चाहिँ फेरि होइन यो डिस्कोर्स चलाउनु पर्छ जस्तो लाग्छ क्या खासमा होइन
हजुर
रिसर्चको कुरामा चाहिँ अब त्यो अगाडिको होइन हिस्ट्रीमा भएको कुराहरूलाई चाहिँ अब कसरी तपाईँले रिसर्चबाट चाहिँ होइन अरूसम्म लाने भन्ने कुरामा चाहिँ त्यसमा डिस्कोर्सै चलाउनु पर्छ जस्तो लाग्छ
हो नेत्रजी तपाईँहरू यो गर्नु भएको छ एकदमै यसले चाहिँ राम्रो भइरहेको छ जस्तो यो आइडिया लिएर आउनुभयो अब सरले गर्दै हुनुहुन्छ अब यसलाई चाहिँ मतलब अब एउटा पोइन्टमा पुगेपछि त सरको पनि अब 15th भन्नुभएको छ त्यसपछि एन्ड हुन्छ होला अनि त्यसपछिको डिस्कोर्समा यो पनि सम्भावनाको क्षेत्र हो धनकुमारी म्यामले यस्तो भन्नुभएको थियो है कुनै बेला भनेर सम्झिनु भयो भने आई गेस दैट वुड बी फ्रुटफुल फर एभ्रीबडी
अच्छा सर भोलि हामीले यो गर्यौँ भने अपकमिङ भनौँ न अपकमिङ के भन्छ यो जेनेरेसनहरूलाई हजुर हुन्छ भन्ने लाग्छ
हुन्छ आजलाई यति गरौँ होला होइन
थ्याङ्क यू है यो बोल्न पाएँ
फेरि अर्को कन्टिन्यू गरौँ होला डिस्कसन
थ्याङ्क यू सर नमस्कार
Thank you everybody.
Have a nice dinner. मसाल भयो
म त अब ब्रेकफास्ट चिया खाने बेला भयो
ओके थ्याङ्क यू दिपक ओके
थ्याङ्क यू म्याडम इन्द्रमणि सर तपाईँ त्यहीँ हुनुहुन्छ माइक म्युट गर्नु भ्याउनु भएको छैन इट्स लाइक रेकर्डेड आई गेस ओके बाइ नाउ